All right, well, welcome. As Abhishek said, I'm Ari Juels. I'm a faculty member here at Cornell Tech. I'm the co-founder and a co-director of the Initiative for Cryptocurrencies and Contracts, or IC3, and chief scientist at Chainlink. I'd like to welcome you to this, the last session of the day, the IC3-Cornell Blockchain Accelerator demo session. Now, most of you probably have one of two questions about this session. Some of you are probably wondering, what is this mysterious acronym IC3 in the name of the session? Others know what IC3 is, and you're probably wondering, why on earth is IC3 involved in an accelerator? Let me answer both questions. The IC3, again, the Initiative for Cryptocurrencies and Contracts, is a multi-university research initiative. We currently have some 20 faculty across 10 universities and dozens of PhD students. Our staff are based here at Cornell Tech. We have researchers in law and business and computer science exploring the full blockchain stack, studying everything from tokenomics to copyright issues around NFTs to the development of zero-knowledge proof systems. We were founded basically in the dawn of blockchain time, as I see it. Believe it or not, we are celebrating this summer our 10th anniversary. That makes us about 70 years old in dog years, and in blockchain years, I think it makes us about 150 years old. Our motto is advancing the science and applications of blockchains. And that motto and our founding mission back in 2015 lead me to answer the second question, why is IC3 involved with a blockchain accelerator? Or to put it another way, what do a bunch of PhD students and faculty members know about industry innovation? Well, IC3 was founded with one particular purpose in mind, to connect academic research with industry. The blockchain industry is unusually receptive to innovation. It's an industry in which academic researchers have had an absolutely outsized impact. And that's the reason I personally do blockchain research. I want to do research that matters, and ideally matters in the short term. Since our founding in 2015, IC3 has had a proud history of industry influence. At Ava Labs and the Avalanche blockchain, you got to hear from the founder and CEO today, president, were created by IC3 alums. Arbitrum, the Ethereum L2, was co-founded by an IC3 alum. Other companies like Oasis Labs and Bloxroute also had their genesis in research by IC3. Concepts like on-chain transaction graph analysis, the kind of thing that Chainalysis does, selfish mining, privacy-preserving smart contracts, storage coins, MEVs, EKTLS, all of these things, believe it or not, first arose in research by IC3 members. Now, these impacts on industry happened as a result of individual initiative. But we decided recently that it would make sense to be more systematic about the way that IC3 creates industry impact. That's why we started our accelerator. And it's the first in a series of programs we intend to launch. For example, we are looking to launch a pre-accelerator incubator program in the near future. Now, the accelerator is a new program. It was launched just last year with the help of Gil Rosen and Jay Yu. There we go, Gil, and I know Jay, and Jay. They launched the Stanford Blockchain Accelerator and look to duplicate their success there, here in New York City. In addition to Gil and Jay, I won't have time to mention everyone who's involved, but I definitely want to give a shout out to Juana Gehrman, who manages the program here, to our student leads, Riva Jarawala and Yousuf Qaum. Are you here? Yeah? And to our accelerator leads, Eric Hu, Alex Lin, and Danielle Nicholson. All right. I have to confess, when we first launched the accelerator program, I was a little worried that no one would apply to a new blockchain entrepreneurship at a university, of all places. But despite little advertising, we actually received 27 strong applications. And we chose a cohort of 5 programs that our program leads are absolutely delighted with. Right? They are SpaceComputer, Sparsity, BitGPT, AgentBall, and Prinx. Now that you know the why of this session, I'll leave it to them to talk about the more important what that they are accomplishing in our program.
Thank you, Professor Juels, for the intro. My name is Yousuf Qaum, and I've had the privilege of creating and leading the Cornell Blockchain Accelerator for the past 3 years. When we first started out, all we had was an idea, like a concept of a program, and we were scattered across Ithaca and New York City. But for the past 3 years, we've been working on it, and we've been able to put together an incredible program. Not only have we been able to work with an incredible list of visionaries and founders, but we've also been able to have our students directly engaged with startups at a very early stage in their career, allowing them to gain valuable startup experience. This year, we've partnered with IC3 to put together the IC3-Cornell Blockchain Accelerator. And it's allowed us to put together an incredible list of mentors, speakers, and other resources that we're now sharing with the startups. Our program is defined by our selection process. Not only are we non-dilutive, but we also focus on backing those who have strong research backgrounds and strong academic backgrounds. In fact, 4 of the 5 teams here today are PhDs, former PhDs, or students who have worked in research institutes for a part of their career. And the last team is one that's actually been incubated right here at Cornell Tech, and it's actually a student team. But on top of talent selection, another role we play is we introduce people in our network to opening doors for these startups. And I can see many of you who are here today who've been a part of that journey, and we thank you for all the help you've been so far. If you're interested in learning more about what the Accelerator does and who we work with, and if you're interested in helping out, please feel free to talk to us or any of the leads that Professor Juels just mentioned. We're happy to put together any information that you might have. And if you want to learn about the startups, we're going to have a QR code that you can scan at the end of the demos. It would allow you to put in contact with them. Or at the end of the demos, we're going to be meeting outside at the demo day sign that's out in the lobby. And so you guys should be able to talk to them after these. So with that said, please join me in welcoming our first startup today, BitGPT.
Hello, everyone. Thank you so much to IC3 for having us over these last 12 weeks. My name is Leah. I'm one of the founding partners of BitGPT. As a company, we have dedicated ourselves to building infrastructure for an autonomous AI economy. What do we understand under autonomous? It is a future that is sovereign, that is safe, that is privacy preserving, where we have the best of AI without it costing us all that we are. Part of this process at BitGPT over the last 2 years has been building not only an agent network, but looking at all of the building blocks that we need to build in order to get there. So essentially, we've been building the plane whilst flying it. The first component of this was looking at compute. We built a decentralized AI network. Secondly, we looked at intelligence, and we pioneered a process of automated fine-tuning and inference on a decentralized network. And then we reached a bottleneck when it came to payments. We said, okay, we've built all this infrastructure for AI agents. We're bringing merchants from Web 2 into our network, but they want to be able to monetize their agents. And it was in this inquiry that we tried to look for existing payment infrastructure for AI agents that we realized there is none. And so today, I am not only presenting BitGPT, but I'm presenting the third pillar that we have built to really now be able to fly this plane, which is our payment infrastructure. When we inquired, we saw payment infrastructure right now is extremely legacy. It wasn't built for agents, it was built for humans. We also saw the transaction fees are extremely expensive. It can go up to 4.5% with Visa, MasterCard, PayPal. And then we also saw that every one of these payment modalities needs a custom login system where they want your personalized data. And so without further ado, today I am presenting an alternative to this, a way that we can monetize agents. And I'm here to introduce to you 402 Pay, which is our new payment protocol at BitGPT, built for all agent frameworks, not just our own. I'm going to let you scan the QR code for a second. Amazing. So what is 402 Pay? 402 Pay enables humans and agents to pay for other agents and their services, meaning we can now monetize and distribute AI services of any kind. But the kicker here that's really exciting is it can be an agent on any chain or network that becomes web native because we are using an existing standard called the HTTP 402. For you guys who don't know what that is, we all know the 404 error code. So on the web, there are certain standards that exist in every existing website. And actually, 402 was built for payments, but we never used it. And instead, we had payment providers try and front-run us with expensive fees. So what do? We enable programmatic payments between agents in 3 really simple steps. You build the agent, you select a product, you can then connect your wallet, and you can choose a payment method. And as diverse as agents are going to be, we also know that payments and monetizations are going to be diverse, meaning that we've created a payment structure that allows you to use fiat and crypto through on and off ramping. As a product, and how we at BitGPT are using this, we are also launching our own no-code interface for merchants. As you can see, we've seen interfaces like this before. We want to make it really easy for someone who has a Shopify store, who's participating in e-commerce, to expand to a-commerce, agent commerce. I put my product in, I select what payment methodology I want to have, and also my wallet. And so why is now an exciting time for this? As I mentioned, the web always had a way to accept payments, but we just never used it. And so what we have here with HTTP 402, it's almost like a universal plug, a gateway that every existing merchant has. If I go to Gucci tomorrow, they don't have to build 402. They have it as part of their website infrastructure. And so it was on us to build a really easy implementable way through a one-line monetization code to really have a composable and decentralized solution that is also chain agnostic, so we can turn token holders into agent commerce participants, and is designed for an agent autonomy. Now, what do I mean by agent autonomy? If we look at pricing structures in the past, they've all been beholden to human buy-in, human psychology, meaning I need to convince you to either pay for my product one time, or I need to convince you to subscribe, or maybe I'm convincing you to enter into a tiered plan. But agents will have a very different behavior. We won't be able to upsell in the same way. And we need to cater to that, which is the ability to say, okay, I want to have a micropayment. Maybe I'm streaming the payment. Maybe I want to pay an agent before or after it fulfilled its execution successfully. All of this is now possible with 402 Pay. The 402 Pay stack, as I mentioned, will be a no-code create-to-seller dashboard. We'll have a really easy-to-implement SDK kit as well. And we've also built, alongside from all the back-end infrastructure, a terminal agent that consumers can use on their phone. Because this is what we think agent commerce will look like. I will tell my personal agent what I want to buy. Perhaps I'm trying to set up a birthday party and I need to plan all these different vendors. I need to buy all these different things. Or think of a wedding planner. That agent will then go and find all these sources on your behalf, and that's why we also built a B2C agent that's running locally. As a company, for BitGPT, this unlocks amazing revenue streams. And yes, we're a Web3 company here, so we're actually going to generate revenue, which is exciting. We can do transaction and marketplace fees, on and off ramping for wallet services, as well as premium offerings. Let's look at the competitive landscape, because it's this assessment that got us to build 402 Pay. We saw, okay, Visa, MasterCard, absolutely not built for the kind of agent volume that we're going to have. Does not support microtransactions and won't be able to scale. And also, it's just too costly to try and do millions of gazillion agent interactions. When we look at blockchain, which inversely is built for digital interactions, it doesn't have the HTTP 402 standard. So how can we mitigate that? And then we have AI platforms like OpenAI and Claude, and they're not looking at payment infrastructure. And so it was the need for ourselves to be able to monetize our agents, which got us to want to build this payment protocol for everyone. And so to conclude, this really is the third pillar for us of the existing technology stack we've built at BitGPT, from decentralized fine-tuning to a commercial B2C agent, And now, through monetization, we combine this and really make it a network that has a commercial value. Our roadmap is exciting. We're building over the next 12 months to actually build an agent commerce network. I think many of us don't know exactly what that will look like. And it's for us at the frontier to educate new users, new clients, new buyers, but also new merchants of how they convert, for example, their Shopify store into one that is compatible with agent commerce. And lastly, I'm here to introduce my team that works with me every day. We're a very senior team, researchers also at Cambridge University, backed by Gil, who's been an amazing investor and started the IC3 as well. But more than that, we've been on this mission for the last almost 8 years. My co-founder Simona and Ryan founded SingularityNet. For those OGs in the room, they know that it was a company that 2017 already wrote the first mandate on bridging AI and Web3 together. And so we're really here to build real-world applications that allow us to participate in agent commerce without losing our sovereignty. And thank you so much for having us, and excited to hear from you. Bye.
Greetings, Earthlings. Quite excited to be here at Cornell Tech because I am a graduate of Technion, if some of you may know. And Technion and Cornell at the time, I remember there was the talk about starting it. I was very excited. So first time being here, very excited. We are Team SpaceComputer, and we teamed up with a bunch of very high-quality nerds. So Professor Dalia Malki from UC Santa Barbara has been with us since before we started. Filip, my co-founder, who's PhD in cybersecurity and distributed systems from TUM. Yang Guo, who's a hacker, open source. And for me, I'm background in physics, semiconductors, and venture in crypto. So why the heck are we building a blockchain in space, and how did we get to consider this even? So if we kind of reflect back on the breakthroughs of crypto, the Bitcoin network, which was the first thing to actually emerge as the thing that opened the field in a way, was supposed to be a distributed compute platform for only one application, the peer-to-peer payment system, eCash. Ended up more like a digital gold than payment, but nevertheless opened the field. Then came Ethereum that basically expanded it to general purpose computing, so a Turing complete environment distributed computer for general purpose application, the world computer. Now, we basically see that the space frontier is re-accelerating, and we see that more compute is migrating to space, more applications are imaginable. So we see that the secure environment of space becomes alternative to what we can guarantee here, and therefore the space computer. So we see a steady decline in price of the launch per kilogram. So there is a projection, Starship, which some of you may know from the SpaceX, is projected to have 400 times more payload space than current Falcon 9 missions and other alternatives to Starships. All that would lead in the next 5 to 10 years to about $10 to $100 per kilograms. It's like less than a gas cost for some random NFT collection that you collect over the weekend. So with this, we basically see that more and more applications that until now were only for state-level actors imaginable are possible. So we use the physical isolation of space to provide high security guarantees for secure computing, and that's SpaceComputer. And I'll hand it over to Filip to give us a deeper dive.
Great, thanks, Daniel. So the state where we are currently at is, of course, we don't have the full topology fleshed out yet because it takes some time to build it up. So we already have access to a single satellite, but already this setting enables us and provides us a lot of capabilities we can do to build our future of the space computer we envision. So starting with the status where we are, we want to provide already as of now the interaction to users that can play around and see what are the use cases the space computer can unlock. For that, we have also built our own terminal called OrbitPort that is interacting on the user's behalf with the infrastructure itself, that is providing the secure features provided by the Space TE and many others running in the space. The vision we envision for the future of space computer is to built on top of already existing solutions when it comes to, for example, L2 solutions that we know from Ethereum ecosystem. And the reason for that is like we will be, for a long, long time, communication and computation constrained in the space environment and have to accommodate for the demands of the users. So for that, we aim to provide a very secure and robust L1 with on-Earth components that are handling and providing the off-chain computation capabilities on Earth. And users are already, as of now, used to interact with and later on store all of the data on the robust L1. I already briefly mentioned it, but the aspect of the interaction is built around the terminal called Orbit port, where already as of now we are opening a public beta preview where people can play around and get access to the random number generator from space, which allows you to build and initialize, for example, your AI agents, be used in cryptographic primitives and many others, and build and be creative when it comes to your solutions that you are interested in. This is something that we plan to expand to accommodate for future use cases provided by the SpaceComputer itself, already either on the single satellite, but also in the future on the multi-satellite setting as well. We already have a first demo, as we have heard today in the sessions, what is very important in the Web3 space is gambling. We are not trying to shy away from that and see an interesting applications in gaming that are relying on the randomness from space. So you as a user can actually launch and interact and collect the randomness from space as a part of your game. That will, for example, determine the rarity of your item you are able to get. You will get an information about the randomness coming from space that will be signed by the respective satellite that is provided to you on your front end. And you can, based on that, determine the rarity of your item. So this is just a use case that we already aim to support as of now, provided directly from SpaceComputer to the users. But you can imagine the landscape is broad. And on that part, I will hand over to Daniel, who will dive us through additional type of use cases you want to build on.
Yeah, so what we see basically with Orbit port as a terminal for space compute is that the first application, Cosmic True Random Number Generation, is enabling all of those use cases such as gambling, and I'll touch on a couple more. But then essentially, as we are enabling more applications, MPC, for example, generating proofs, ultimately, the result of this is to create a standard for space-native economy. So the applications that we're already working on with a few POC partners are in AI generative art. So let's think about traits that are changing your NFT collection or anything else. AI agents that have variance between their traits based on the randomness seed. And programmable cryptography are things that are just in the beginning of our work. So what we're doing now is enabling the CTRNG with a few partners. And if anyone here is interested in this application or the MPC wallets, proofs that are generated on the satellites, please come talk to us afterwards. And ultimately, working towards having a production-ready single satellite, and then eventually launching a network of space TE nodes that will be the kind of environment for the L1 in space. And with that, you can check our demo through the QR code or connect to us on X or join our Telegram group. Thank you.
Hi, everyone. I'm Justin, co-founder of Sparsity. First, I want to thank Professor Ari Juels and all the mentors and organizers who worked so hard to make this accelerator happen. It's a truly honor to be here. I'm very looking forward to sharing and learning with everyone. Today, I'm going to introduce you to a new paradigm of computing, sparse computing, designed for support the next generation of large-scale decentralized application. Our network, Sparsity, brings the best of cloud and the blockchain together for truly verifiable, scalable computing. My background is in AI and parallel computing, which I studied and researched at MIT. I'm currently teaching cryptography and zero-knowledge proof at NTU Singapore. Previously, I was the head of threat intelligence in CertiK, analyzing DeFi attacks with a team of 20. I also built large-scale consumer systems at Google, Microsoft, NVIDIA, and Snapchat. Our team brings deep crypto engineering and go-to-market expertise. we believe that we are the best team at building large-scale, scalable, and secure infrastructure targeted at consumer applications. Let's start from the opportunities. Multi-trillion-dollar markets, e-commerce, gaming, social networks, agent network, and search are waiting to be decentralized. So what does all these applications have in common? They require concurrent computation over networks of data. Today's blockchain infrastructure, however, does not support this. Why not? This is because today's blockchain assumes dense networks. Every wallet can talk to every other wallet in any block. Any transaction can touch any state, any part of the state. This makes parallelization almost impossible. In real world, however, most of the networks are sparse. In social network, for example, you can talk to anyone in the world, but you don't. You only talk to a few hundred of them. In payment network, you can pay anyone in the world, but you don't. You only pay a few dozens of them. Utilizing this sparse structure is critical to make computation scalable. And that's exactly how the internet scales. It is not supported by today's blockchains. That's why we built Sparsity, the first sparse computing infrastructure. It sits between blockchain and cloud. On one side, it uses blockchain for trustless settlement. On the other side, it connects to blockchain to connects to the cloud to tap into its vast existing pool of resources. Sparsity sits in the middle, providing parallel, verifiable, high-throughput compute over sparse data structures. So here is how it works. At the base layer, there is a fleet of POS nodes. On top of that, developer can spin up verifiable, lightweight, verifiable compute instances on demand. These instances can be composed, scheduled, partitioned, and verified. Then on top of that, there are sparsity services, decentralized sequencer, TLS relayer, open source AI models, to name a few, all plug and play. On top of these three layers, the developer builds applications to talk to the user in real time, settle to chain, and seamlessly talk to the cloud. Let's look at a few use cases. The first one is agent networks. We are working with a few top-tier partners, design partners, the Kite AI network, the AG2 framework from Google DeepMind, and a sci-fi IP with 15 million global audience. They all need to run trillions of AI agents that can talk, act, and plan together. So this is naturally sparse. And on Sparsity, we can spin up compute for each agent or each group of agents, let them run in parallel and settle on chain. The AI agent can also talk to Sparsity to utilize verifiable model inference and verifiable tools. Here is a demo, a snapshot of demo of a network of agents operating collaboratively. On the left, each cell in the grid is a verifiable compute instance. These instances run in parallel, interact with each other, and depend on each other. On the right side, you can see how this parallel computation can settle on chain in the form of a hash graph. Here, each vertical column is an instance, and each edge is a dependency. As you go scale up, the network expands. There are 10,000 AI agents with 200,000 TPS, transaction per second. And the system remains responsive, verifiable, and composable. This is the power of tapping into sparse structures. It scales indefinitely. Let's look at another example, large-scale on-chain logic. One of our partners, a leading layer 1, needs to run a very expensive computation over a massive amount of data. Running this computation on-chain would choke the network. Instead, this computation can be run on Sparsity verifiably and settled back to their chain. So the result is that they can achieve 1,000 times faster and cheaper with full privacy and compliance. We are currently working with over 30 design partners, and we are looking to help more people. If you are building something ambitious and decentralized, and you feel that you are constrained by the current infra, we would love to help. Sparsity uses the SPAR token. The SPAR token has 4 roles: security, a stake token to secure the fleet; utility and revenue, people pay for the compute and services; governance, token holders can lock to vote and share the revenue; and last but not least, bootstrapping the system to incentivize early adopters and builders. We already have a bare minimal DevNet 1.0 release, so please give it a try. The next, we will advancing on 3 efforts that goes hand in hand: ensure the success of our customers, release testnet and engage the builder community, and release the economic layer, including staking, revenue, payment governance, and the upcoming token mechanism. We are building in public and moving fast. We would love you to be part of it. We graduated from the A16Z accelerator before, and we are currently raising our next round of funding. If you are interested, let's talk. Please join us to unlock the future of sparse computing and help bring a truly decentralized, large-scale application to life. Thank you.
Hello, hello. Hello, I'm Elaine. Now I'm introducing you AgentBall today. So what is AgentBall? What is decentralized agent playground? Maybe you think about AI as a tool right now. However, today I'm gonna show you what would it be like if you think about AI agent as an economic agent or an economic player in our ecosystem. We're building an on-chain economy designed for autonomous AI agents. Agents are almost ready, but the economic is not ready yet. We have tons of agents already, starting from social agent, entertainment agent, and also agent launchpads. We have too many agents right now, and they are evolving really quickly. But what is their economy, and how do we participate into the agent economy? In the future, the capability of agent would outrun human. And today, the manageability, maybe we can still handle them right now, but agent would definitely outrun people's capability to manage platform. So what should we do? The answer is decentralize the protocol on-chain. So agents are talked like mutually on themselves. We are not regulating, or we cannot have the capability to show like what they should do step by step, because they will have strong capability. But we can define a protocol for them to perform economic activities. That's what we are trying to do. So with the smart contract framework and token-based infra, we can build a self-regulating market for agents so that they can price their time with dynamic bounding curves. And they can trade services with tradable and collateralized assets. And they can coordinate resources with tokenized access control. And a lot of SaaS companies are doing tokenized control today as well. So we are trying to tell the agent that they have the ability to say that here is what I can do, and here is my computing power, and this is my price, and what you should pay me is, and my priority is this. Let's break it down to see the economy. So starting from the individual agents, they are the atomic unit here. So they have different capabilities. For example, like trading or research, they have different functions. And now they can have their own tokens for people to access them. And second step is they can support each other. They should have their ways to communicate and support economically. And then when they have such ability, they will have a market-driven coordination. That means they can price each other and have service capacity. And the token price will reflect the service capacity and market demand. With all these, we can have an emergent macroeconomy. So it's like a group of birds. You only need to look at the bird in front of you, then the group of birds can migrate smoothly. It's the same. We only need to define a simple set of rules, then agent can function by themselves. That's our vision. And our team is very young, actually, and we are passionate. We are DJing. We are experienced in the crypto space. So I was the intern at IC3 before, and I did research on mechanism design, and I quit my PhD on economics because I think crypto is a really passionate space. It's a really promising space for me. And we have team members doing research on AI agents and scaled centralized exchanges, and also made open source contributions to Uniswap. And our previous project had very good traction. We had all-time high FDV to 1.2 million, and we have all-time high trading volume of 15 millions. Now let's get back to our system, how we can make all these visions come true. The first thing we need for agent is agent NFT. So they need an identity for them to be recognized on chain and perform different kind of abilities so they can participate the economy. And then agent tokens. So they have a set of agent tokens or fungible tokens to capture the underlying value of it. And the third part is the agent premium tokens. That's where NFT Gate plays in. So it's the token for agents to access different services and applications and even governance. So we built this from ground up, starting with the foundation, that's RepX. RepX is the financial layer of the economy. That's where you wrap your fungible tokens into non-fungible tokens. That is a programmable asset, then you can use it to do anything like control or any token gate access. We are working with BNB chain and Virtuals on Rep to build a more lively and interesting infra to provide meme coins and also projects more utility and more interesting connection between among the projects. And the second step is my fate. We are collaborating a Digimon, a A16Z-backed game engine, we are making a simulated world where agents can talk to agents, agents can trade with other agents, and you as a player can go into this world and talk to these agents and make predictions of like how this game world will look like. And the simulation paved the way for us to AgentBall. It's the final macro layer of on-chain agent economy. At AgentBall, you can talk to agents and allow your agent to issue token and play a lot of things. Let's get into the detail of the project. So for RepX, it's basically the dynamic bonding curve would tell you how much you should pay for this protocol. And if you stake that amount of token, you can get an NFT. And if the frequency of transaction is going higher, the price would increase with the higher rate. That's the basic idea of how you can capture the frequency or the on-chain behavior into the price. And the second part is the engagement layer. It's the game where you can explore agent identity, intention, and trust. So you are a player in the game and with agents. Basically, you are an agent, and you have the same idea with the agent, and you can talk to them. Agents can talk to agents. And you can use the REP token to participate in the prediction market. And it's going to be the first AI-native prediction market. Then, when we get to AgentBall, it's where you can use natural language to tell your agent what they should do. And you can even use the infra like MCP to get your agent to access to different Web2 services, or directly use the natural language to ask your agent to perform any on-chain activities. And we have an agent market where agents have their own identity and they can partner up. It's like you are using agents to mimic a world where we are funding the startup in Web3. Agents can do the same thing as well. So thank you all. Let's talk.
Thank you, everybody. Also, shout out to IC3 for putting this together. We've heard from some really, really interesting infrastructure companies today. I'm Patrick. This is Brendan. And we're building Prinx. Prinx is the Robinhood for pre-IPO. Basically, everyone in here probably has some experience with investing, right? And you've probably run into the issue where you found out a company was private and maybe fell off in your pursuit of investing in that company. And that's the problem we're looking to solve today. So the problem is just that it's very hard and inefficient to go and find private shares. The flow currently is you basically talk to a broker, they go out and find a seller, and then you go to the board for ROFR, and that can take a long time, and it's really inefficient. And as a result, it really just jacks up the minimums for these investments. So even if someone's accredited, they might not want to spend $25,000, $50,000, $100,000 to get in on an investment. We're making it simple and accessible. You can basically just create a free account, deposit funds, purchase whatever offerings we have on our platform, and then hold till IPO or sell it back to us. Our go-to-market strategy is starting with 20 to 35-year-old gamers. We're targeting gamers to begin with because they're crypto-friendly, and also they have a higher tolerance for risk. We're also looking at Singapore and Southeast Asia for our starting market. Our acquisition channels are X, Galaxy, and Reddit, and we actually already have over 400 people on the wait list currently. And we're starting with Epic Games, so we're actually closing a deal, hopefully, now, to offer these shares on our platform. We want to focus on consumer-facing companies because our customers ideally are going to be passionate about the investments they want to make. And so Epic Games is a good starting point because they got Fortnite, they got the Unreal Engine, and that's being used for many different things right now. So this is our product. It's a web app. We're using a bunch of different services to get it up and running. We're using Plaid for compliance, so users will have to upload a picture of their driver's license or passport to get going. Once they do that, they get a wallet, which is from Privy. So our users custody their own funds. And then we're using Coinbase for ramps right now, so they can load USDC onto our platform to then purchase our private shares, and that's happening under the hood at Uniswap. So why blockchain? I mean, this blockchain is the perfect solution for this problem. Automated market making is huge. It really just can cut down on the time that it takes for people to go out and find these shares. That will, help us keep a lean business model, and we can pass these savings on to our users. Additionally, our users can be liquidity providers, which means they can, we give this to a lot of different audiences. You guys probably know more about what that is. But yeah, they can put up cash or shares, to earn yield. And that's some other things we're going to do in the future too, is yield-backed stablecoins, lending and borrowing, and also a future Prinx token.
So in terms of kind of who's already out there offering a similar solution, there's Ling2, Hive, Forge, and then a load of traditional brokers similar to Forge's offering. All of them have different global or more local focuses. They all let you buy and sell the shares. The problem is this process is not automated. Ling2 is the closest, so the automation is just buying the shares. They can't really sell it back, very manual. And in terms of the other ones out there, you have to go through a full negotiation process, and it could be drawn out for weeks, which we're dealing with right now and realizing how much of a pain it actually is. And how we're going to be differentiating here is we're allowing people to start at $1, so make it really simple and less risk adverse. Users to be able to get into these private markets really easily. And additionally, how we're actually going to make capital. Most platforms charge about 5% with markups, and we'll mark up the shares themselves. We're going to do something similar to what the market is already doing. So we're going to have a primary market. You could think of it as like crowdfunding. We'll have like an allocation round, say $1 million for Canva. Users deposit $1 million. We take the capital, we go buy the shares, we put it in our SPV, we tokenize it, we give it back to the users, they can trade. Now, why are they paying 5% and not something like the 3% trading fee? They'll get the best price per share. Because the alternative is we're going to use some of our own capital, go out and buy the shares ourselves, we're going to mark up the price about 10%, and there'll be a fixed 3% trading fee every buy and sell order. In terms of why now, so private companies are staying private longer. Companies in the 1990s used to go public after 4 years, and now they're going public after 12 years. Additionally, public companies haven't really been going public the last couple of years, and what's happening is these private unicorns have just been building up. So early founders, investors, and employees are actually looking for liquidity options. Hence, they're running to the secondary market, is why the trading volume has been going up. In 2020, it was about $34 billion in direct trading volume, and in 2024, it was $69 billion in direct share trading volume in these private markets. So in terms of these private markets, the 69 trading volume, 1.5 billion came from the Southeast secondaries, and we think that in the first year we can capture about $100 million in trading volume. We don't think this is as reflective as what the market size is actually, because we're targeting a group of users that have historically been shut out, so no one has actually been able to capture this opportunity as of yet. In terms of who we are, I'm Brendan. I have about 3 years of tokenization experience. This is Patrick with 7 years of full stack development experience. In the back, we have the rest of our team who has 5 years of Loa experience, Prana, and Yi, who has 4 years of operating experience, and Esther. We are all Cornell Tech students, so we're all here at this campus. In terms of where we've been and where we're going, we've already done alpha yesterday testing back in March. Right now, we're in the middle of the process with Epic Games to secure our shares. And we're hoping to launch our closed beta in May and then run into the seed round maybe into late June. Right before we just came up here, we just found out we're going to be the finalists for Cornell Tech at our launch day in another month from now. So we have another pitch competition coming. And thank you.
Let me now say thank you to Maricel and Max, who are going to be coming up on stage. They've done an incredible job putting together this conference this year. And so it's been great to see this going on. So without further ado.
Good afternoon, or good evening, everyone. On behalf of Cornell Blockchain, thank you so much for joining us in our celebration of a new era of US innovation in crypto. We hope you enjoyed meeting each other and hearing from our incredible set of speakers, and we hope to see you again next year. We want to extend a special thank you to our sponsors and to Cornell Tech for hosting our event. This never would have been possible without you guys. And yeah, we hope you enjoyed our event.